real exam questions. This is question 47, and it's about column design. Consider a column with a square cross-section with side A and the concrete grade of C3037. The buckling length is L0, from which load degree N does buckling no longer play a role in determining the load-bearing capacity of the column. Now apply this to a column with a square cross-section wide, side A is 300 millimeters, and a buckling length of 3 meters. Round your answer up to 1%. What is the maximum load on this column in ULS persistent at which buckling plays no role? The in second order effects may be ignored if the slenderness of the column is below a certain value lambda limit. So lambda limit is given by 20 ABC divided by the square root of the load ratio, with in general cases A is 0.7, B is 1.1, and C is 0.7. So it gives you a total of lambda limit is equal to 10.78 divided by the square root of the load ratio. The slenderness of the column is equal to L0 divided by E, which is the effective length divided by the ratio of gyration. And the ratio of gyration is the square root of the surface moment of inertia of the section divided by the cross section and then the square root of it. When you work this out for square cross section, we have this expression. So now, to be able to ignore second order effects, lambda must be smaller than lambda limit, or those two equations, we got this expression. If you fulfill this expression, you do not have to take second order effects into account. We can write it as the load ratio is then, from this, is then equals to 10 times A over L0 squared. So we have lambda smaller than lambda limit. We calculated the value of N, or the maximum value of N. Now we will put in some numbers. The size of the column was 300 millimeter. The effective length of 3 meters. And the load ratio is then, following this formula, equal to roughly 10%. The load ratio is defined as the normal load divided by the cross section and divided by the design value of the concrete compressive strength, and this is 0.1. So the maximum load on the column with a size 300 millimeters and a length of 3 meters cannot be loaded more than 153 kilonewton. If you load it more than 153, then you have to take second order effects into account. It means roughly that you have to take second order into account in most cases.